Now, for this question, okay, you're given 3 points. You're given 3 points. And you have to find the equation. And these 3 points, they're not indicating anything. They're not indicating that they are the endpoints of a diameter. Nothing. Okay? Nothing. Now, I want to show you the answer key. This is the answer key. So the idea behind the answer key is that, well, you got 3 points, right? And you got the 3 points, you got the X, Y values of those 3 points. So technically speaking, you can actually substitute in the X and Y, and you are left with the D, E, and F, 3 unknowns. And you have 3 equations, you've got 3 unknowns, you can find it out. Do you like this kind of work? Okay. I don't like it either. So if you do not like this work, then I'm giving you a way out. First, sketch the circle. So so you have a circle that would intersect, or they would touch all of the points right here. So something like this. Okay. Now, if you don't want to do systems of equations, then you have to do geometry. So the way that geometry is done is this. Now, you would go ahead and draw out the chords that connects these dots. Okay. Now, these 2 blue lines, we could find out the slope. Okay, how about this? Let me go ahead and label this first. This is 1, 7. This is -2, -2, and this is 8, 10. Okay, so let's go ahead and be curious. What's the slope of the first line right here? It's negative for sure. And we say change of y. What's the change of y is 3. Oh, -8. Sorry. It's -8, 10. -8, 10. All right. So the change of x is 9. So the slope for this line is -1/3. What about the other line? Well, it's positive slope going up. The change of y, it's 9. The change of x is 3. So the slope is 3. Oh, they are perpendicular to each other. So now, a lot of people they wonder, like, why do we have to learn these things? Or I would say now is a good time to see it. If you know your geometry, this problem could get a whole lot easier. If you can find out the slopes of these 2 lines and somehow you figured out that they are perpendicular to each other, that means the angle right here is a right angle. There's a property of circle, and that is, if you draw 2 chords intersecting on a circle from the endpoints of a diameter, it will always equal to, or it will always form a right angle. Or do you still remember that this is the angle of the arc, which is 180 degrees? And if you draw 2 chords on the circle, this angle is always half of the arc, half of the arc's angle. Okay, I think you need to know that for SAT as well. I think. Anyhow, so if you know this particular property, you can go ahead and claim that -8, 10 and -2, -2, they are the endpoints of the diameter. And you can just repeat the same thing that we did in the last question. So do we have to do all these? Now we know geometry. We're smart. We don't do this. But now the question is, what if this is not a diameter? What if you never knew that they intersect each other at the right angle? So I want to present something to you here, and that is, if there's a center, and there's one property of circle that goes like this, that if you draw, oh, actually I should use a purple line. If you draw a straight line from the center to cut at the chord at a right angle, this would be the midpoint, and it would cut the chord into 2 halves. Okay, same thing right here. Okay, it would cut the chord into 2 halves. Now, how is it useful, we ask? Well, we say this. We say, well, since we know that they are perpendicular to each other, let me go ahead and label this as L1 and L2. So I'm going to ask something. I will ask, hey guys, do you think you can tell me the slope of L1? I would say, yeah, because it's perpendicular, right? So it must be the negative reciprocal of the blue line. So the slope of this L1 must be 3. Could we know this point? The midpoint on the blue line? We say, yeah, that's the midpoint. Just find the average, right? So if you have the point and you have the slope, what can we do? We can find out we can use the point slope form to find out the equation. And what we can then do is to find the intersection of these 2 equations. That's a center. So if you don't know that these 2 points are the endpoints of a diameter, that's your survival. So the midpoint of the first blue line that we need, the top blue line, the midpoint here would be the average between -8 and 1. So we add them up and divide it by 2. So we have -7 divided by 2, which is -3.5. And then we have 10 plus 7 divided by 2. That's negative, no, that's positive 8.5. So we got a point, and we have the slope. The slope, it's 3 for L1. The point, it's -3.5, comma 8.5. Okay. So so what we can do is y minus y1, which is y plus, no, sorry, y minus, because I don't know why I put in a negative here. Y minus 8.5, it's equal to 3 times x minus or x plus 3.5, because minus 3.5 for the x value. So you would have 3x plus 10.5, and then you would add 8.5 there. So you've got what? You've got 3x plus 19. So that's the equation, okay, for L1, okay, and we do the same for L2, and L2 could be a little bit more challenging. L2 slope, it's -1/3 because of the negative reciprocal of the blue line slope right here, okay, and the midpoint between those two. So -2 and 1. So you would get the point at -0.5, comma 2.5. Okay, so we got a point right here, -0.5, comma 2.5. Okay, so So you have y minus 2.5. It's equal to negative 1/3, and then x minus or x plus 0.5 or 1/2. Actually, I'm going to change it to 1/2 because we're going to have some fractions to deal with. So negative 1/3 x minus 1/6, and then add 5/2, which becomes 15/6. So negative 1/3 x plus 14/6, which is 7/3. Okay, so you simplify it. 14/6, it's 14/6, it's 7/3. So now we have these two equations, and they will intersect together at the center. So we say 3x plus 19, it's equal to it's equal to negative 1/3 x plus 7/3. So the first thing that I would do is to multiply by 3 on both sides. So we got 9x plus 57, negative x plus 7.